Okay, yet another one of our more recent USDA companies in our commercialization program is Micronic Technologies, developing a wastewater treatment, a state-of-the-art wastewater treatment, removing all contaminants from any source of water. And that's why you've heard Karen over the last couple of days ask some pretty interesting questions and put up her hand whenever she can with a very loud voice as well and a personality to boot. So Karen Sorber.
Thank you very much. Okay, so you have two more people after me. You must be anxious to get out of here after 3 days. How would you like to learn about a breakaway technology that cleans water from any source? Yay! All right. I'm Karen Sorber, and I'm the CEO of Micronic Technologies. I started this company with my husband, the inventor, in 2008. I had been to Peru and saw devastation in communities that had no water, had studied the African countries and their problems. My husband, an inventor with 22 patents in his background, had the idea of desalinating water. I thought, great, this is what I can do in my next career, because I had spent 35 years culminating in senior executive positions in the DC area. You can imagine I was looking for something different. And he wanted to make a difference also. So we've developed a technology that's actually going to help preserve the world's water resources through people like you. Thank you very much for being here. I want to particularly thank Bob Calcaterra, Bob Morris, and of course Rahit for the opportunities to be here, and our client, Cleland. There you are. He's our USDA client. It's been wonderful to work with. Okay, so we studied the market, and we found out that there's a lot of uses for water. Hundreds of billions of gallons a day are used. And if use isn't necessarily the biggest problem is it's not reused. We all know that there's a finite amount of water in the world. We have to reuse it. 69% of the water that's used in this country is not reused. Our technology, breakaway technology, can reuse water from any of these industries. There are a few people that thought so too. We have a $2 million grant from the Tobacco Commission in Virginia, and it is for R&D and development and pilots. We have $650,000 from, over the last couple of years, from USDA, and we have $400,000 from the Office of Naval Research. These grants are putting us into a footing to get another $2 million in the next 6 months, and we're looking for $2 million in match that will leverage the $5 million that will have come into the company to scale it up to a very large opportunity. So there's the technology. Think of a tornado, right? Just like in nature, water and air comes in to the patented pods. We have 3 issued patents from the USPTO. The pods are intricately designed and create a tornado when water and air comes in. Instantly evaporates the water. So you think evaporation or distillation, but it's not under heat. It's low temperature and low pressure. Not only that, this summer, we have now proven that at small scale, it is 1/10 the cost of distillation. Cleans anything out of the water, 1/10 distillation, 95% efficient. So how does it do in getting this stuff out of the water? Well, 94% removal of 34 contaminants that we've studied over the last several years. And in the agricultural space, see if this thing works. Here, your NPK, it knocks it out of the water. So it takes care of agricultural runoff. We did a major study for USDA on that and killed it. Also, bacteria. We've done 3 or 4 major studies, including landfill leachate, went from over 400 count to less than 0. We can get out the bacteria. And the EPA standards, we're all over those. 88% of the trials met EPA standards. TDS, if you're interested in that, we can do 380,000 parts per million down to less than 100. So how do we compare to the competition? If you see in the top line here, you see that we can take care of all these kinds of constituents. Whereas normally with various traditional processes for cleaning water, you would need two or three of them to do it. So there's a reduction in CapEx, there's a reduction in OpEx, and it cleans it better. Here's the team. I've built organizations my whole life. We've got Dr. Don Jordan, fabulous PhD in aerospace engineering, a heat transfer expert, and his protege is here. If you'd like to take a bow, Andrea Pera. She's our new mechanical engineer, along with our environmental specialist, Brianna Stallard. You've seen them at our exhibit. And then, of course, Kelly Rock, who has 24 patents now, is truly brilliant man, and my husband. So what's our competitive advantage? We can go to the farms, on site, clean the stormwater runoff ponds, lagoons, and then it can be reused for cattle drinking on the Ogallala Aquifer. Additionally, acid mine drainage, there's 500,000 of them across the country, and they need us to come to them as well. Portable, one-pass solution, cleans everything in one pass. One pass. Here's our financials. It's based on the Ogallala Aquifer. I'm very interested in that, not just because of the farming and the drain on water, but also there are at least 14,000 oil wells in New Mexico that need cleaning as well and reduce the strain. So what do I need? We've got a lot of programs. We've had a lot of success. We've had a lot of press. We have $3 million worth of grants. We need $2 million from a strategic and/or VC/private equity firm to come together to get us to the scaled position of 250,000 gallons a day that can take care of the entire market. So with that, I'll take questions, and thank you very much.
Questions? Yes, sir.
Is the throughput of that device sufficient that you can have saline aquifer and freshwater?
Yes, sir. There's 95% throughput on this system. So 100 gallons go in, 95 are going to come out clean. Just a 5% brine.
But the speed of the process is what
Well, right now, we're at 1,500 gallons a day that we're doing for USDA. We're doing a field pilot this year for that. And we're going after a $2 million grant with Virginia, which I'm virtually assured that we will be on the very short list of getting that. And that's for 250,000 gallons a day. So that's how we measure our production, is gallons per day. Who else? That was your job.
Well, you can go ahead, dear. I'm not at all. Yeah. You go right ahead.
Someone?
Yes.
Your technology cleans the water. I understand that. And if you were, let's just say you're in the animal husbandry space as opposed to mines or something else, and I can imagine how the dirty water is collected and stored and input into your system. But where does the output go?
Okay.
Captured in a useful way.
Right. So we call that the waste stream or the brine, right? Is that what you're speaking of? Oh, the clean water.
Yeah.
Well, usually people want the clean water.
Well, where are you going to put it, is what he's saying. Once you actually clean the water, what are you going to do with it? Store it, drink it,
Yes. Yes.
pass it through something else, who the hell knows, right?
It'll be available for land applications, certainly, because it's essentially drinkable water. So if you don't need the water, it can be used, you can put it on land application. That's what we would do in the acid mine drainage. In the case of the Ogallala, they would use the water to water their cattle. I don't know every application. It depends on the source water and what it is, how rare it is, how much they need the water, and for what purpose. So it's not determined by us, it's determined by the customer. Does that help?
Yes.
Let's talk some more.
So where's your revenue stream? Is it on people who need their water clean, or people who want clean water, or both?
Could be any of the above. In the short term, in the farming community, it could be selling the unit to a co-op, for example, right? And it would be sales of the unit. Revenue streams could also come from licensing the technology and leasing the technology. And we've heard from some farmers that they would want to be able to have it as a service.
Why are you backing up?
I'm not.
Okay.
It has a mind of its own. We've been trying to take it
Right,
off the loop.
All right.
Does that help? Who else? Yes, sir.
Control it with something that's got a very high mass inside the actual water. I think in that dairy effluent runoff.
Right, so suspended solids,
Lots of it, yeah.
a lot of it. So we have at our booth, we have an example of stormwater runoff that I did that was very heavy with the mud. We put mud in it, and that's right, yeah, so yeah, we can do it. We've gone from 10,000 NTU down to nothing on suspended solids. Not so far, but we've done lab prototypes. We're just getting ready to go into the field. So we'll be doing more testing on that. But there's no moving parts within the system, and the water flows through with 10% in order to keep it going.
You need to do the same thing. It needs to be hygienic.
I'm sorry, say again?
Where the output needs to be hygienic, like milk.
The output has to be hygienic in the case of this particular
You mean
kiwi
sterilized?
application.
You mean it's clean? Oh, yeah, this is all very clean. It's potable water.
No, the output.
You mean the brine? No, it's nasty. And we're going to cultivate it for rare earth metals and phosphorus, which is why I want to talk to you, and for powdered milk, which is why I want to talk to you. And oh yeah, there's value in it, but you can't expect to use it immediately.
Okay, we're going to go to this guy from Earth Institute in Columbia University.
Let me, so great, first of all, great to hear this. In the developing world, I can see a lot of applications. How does it compare to basic UV and chlorine in terms of
Sure.
even though it does a lot more than that?
Right. So UV takes the bacteria out, right? And so do we, but we take everything else out. And the other one, chlorine, chlorinates things usually at the end of the process. And if you're drinking it immediately, you wouldn't need that. But if you were going to store it, you certainly would.
But compared to that, is this 2-3 times in cost? Or?
Well, the way we can currently evaluate the cost is it's 1/10 the cost of distillation. So that's how you can compare it. And we've got lots of data and wonderful graphs that Andrea can show you.
Great, thank you. Thank you, Karen, appreciate it.
Very well. Thank you very much.